Hello everyone, welcome to my first YouTube channel, and in this channel I am going to share some of the basic concept of C and C memory layout for a static, global, const and static const variable. So before going to start where these variables are stored, let me define first. What is a static variable? In my way, I can define a static variable as a static local variable and a static global variable. A static global variable are those variables which is used by all C functions in a same file where they are defined. And static local variables are the variable which will be used by a specific to the function inside that it is defined. Once a function change the value in one function call, the value will be remain same for the next function call. That's the benefit of local static variable. Now, global variables are those variables which can be used outside of C files. So other .c file function can also use that global variable using external keyword. Now, constant variable. Constant variable are those variables which you cannot change the value by its name, but in certain condition you can change the value by using the memory pointers. For example, constant global initialize variable you cannot change because it will store in RO data section. I will explain what is RO data section later in the slide. The last one is a static constant. This is a special kind of variable which value cannot be changed even it's local, global, initialized, uninitialized. So let's start with all these variables where they are stored in memory layout. In this session, I am also going to use a live debugging session where we will use these all variables locally, globally, and we'll try to see where they are stored in .text, .ro data, .data, and .bss section. These are the commands I'm going to use, so you guys can use these commands also for the debugging live session. Okay, you will get all my codes in my GitHub channel. Also, you can get these slides in the same C basic concept folder inside my GitHub channel. This is the code. These all are the codes which I'm going to use for the debug session. And as you can see, I tried to make a divisions for the global variable, static global variable, constant global, and static constant global variable. As well as I wrote few of the local variables also, just try to demonstrate that how these values are going to modify or which value you cannot modify. So as I told you that few of the C memory layout concept like .text, .ro data sections, what are these sections, where they are stored. So if you see the C memory layout, you will see these are the virtual memory layout. Why? When a processor execute any instructions, that instruction is stored in a virtual address space. Now, the processors have MMU which will convert this virtual address into physical address. So these sections used by the system use after that you will see this code segment. The code segment have more than one sections. .init, .text, .ro data and other segments are also there. These sections only read, so you cannot edit it. That's why if any of the variable is stored in .ro data, it's only read purpose. Read write segment called data segments. So we have .data section and .bss section. .data section contains all the program data which is initialized. .bss contains just a symbol and it will be used later at runtime when you change the value. So if you see .bss, its size should be fixed. Some of the compiler I saw it's 8 byte, and for me also it's showing 8 byte, but sometimes you can see 4 byte also. So this is the fixed size of .bss based on the symbols. Now, this area is a heap area which is runtime area which you allocate using malloc, calloc, realloc, and the size of this area is fixed using the system call break. Also, we have a common memory shared region where we have shared library, runtime shared library, IOMM memory, and page shared information will be here. Whenever a function is called in a C program, they will create a stack. So this stack is created at runtime and it will grow downwards. Always remember that stack pointer will be always pointing to the top of the stack, and we have some args and environment variable stored on this address, and this is the kernel mapping virtual address space which program directly cannot access. Yeah, we have some other way you can access that. Program can move from the user space to kernel space. So let's start our debugging session. And in this session, I already have a small program written in this basic in C folder. As you can see, I have the cmem.c. And in the cmem.c, I just mentioned few of the global and local variables. As you can see, a lot of variables are commented. So let's try to comment these static constant and the constant variables. As you can see, only one global unslashed variable is there in the program. Rest all things are commented. Let me try to compile. So what I can do is gcc hyphen c cmem.c. So it will create a object file. Yes, it's created. So there is no compilation problem. gcc hyphen s cmem.c. So I will get my assembly. That's true. We can see the assemblies. So as you can see, our main assembly is here and other stuffs are there. Okay, cool. And let me try to make the, the final a dot out. I'm just assuming a dot out is standard way we can do it. A dot out. So now, what is the size of each and every section which we are focusing here is text, arrow data, data, and BSS. So I using this command and try to grab only text, arrow data, data, and BSS. So you can see arrow data is taking 4 byte right now, data is 16, BSS is 8 byte. Let's go to our program. Now let's start with this static constant static global variable. I wrote dot arrow data section. If you remember my previous PPT presentation, I told that whenever we write a static constant variable, it will go to arrow data section. Even it's global, local, initialized or uninitialized. So let's see where it's going to store. So I uncommented one more variable. See what is the total size here. So yeah, just remember that arrow data is 4 byte. Now I'm just going to run. Arrow data is now 8 byte. Rest things are same. Looks like arrow data got one 4 byte variables. That's true. So now if I will say here that this is an arrow data section, doesn't have any dot. Okay, let's try with another variable which is constant int variable which is unsliced. Okay, so where it's gonna store. Okay, for just a hint, in as I already mentioned that if a constant variable is unsliced, it should go and globally it should go in BSS section. So let's see it's going in a BSS section or not. Let me compile it and try. So now BSS is 8. BSS is now 16. So BSS size is increasing by 8 bytes in alignment. So it means he got a new variable and he got a new alignment of 16 bytes. So BSS have one symbol, one more symbol information. That's why the BSS size is increased. Now let's go to the local static constant variable, just like the global. So either you write, I told you a static constant, even initialize, uninitialize, it will always go in arrow data section, even local or global. So let's take easiest way without initializing. So now again I'm taking a local variable. Ideally, it should go in arrow data section. We'll check that. Compile it, run it. Remember we have arrow data 8, now arrow data is 12. Rest things are same. Data section 16, BSS 16, just like same. So arrow data got one more variable. So I take one more variable and this variable is static. I'm assuming it will go to in dot BSS and I try to take one more variable which is global and it's just a global variable. So I'm assuming it should go to BSS if I remove this. because I already have same name, so I just make underscore one as a variable name. That is completely okay. Now BSS is 16. Will it go to 24? Yeah, it is going to 24. So in this live session, you saw that static constant even is uninitialized, or if you try to make it initialized also, will it change any value? I don't think it will change anything. Compile, run. See, there's no changes. It is still there in arrow data. So my point is, even you make a static constant as initialize, uninitialize, or initialize with zero, it will always go to arrow data section, either as global or local. But constant will move if it's constant without initialization will go to dot bss. If a constant with initialization, it will go to row data sequence. Okay, that I forgot. So const int c g variable I for initialized. Let's say I is equal to 10. Wait, so I created one more constant variable which is now initialized and global. So in my opinion, it should go to row data section. So is the row data section getting one more variable, one more 4 byte? Let's see, compile it. So row data is now 12. Now it's 16. So in the sense is the constant variable, if you write with some value as an initialized value, and if it's global, it will store in .row data section. So few of the information I try to demonstrate here, and rest you can take my exercise. The code is in GitHub. GitHub, you can take that code, you can run it, you can uncomment it, comment it, and you can check each and every section. And yeah, that will give you more clarity where they are going to store. So I hope you like my live session and also my presentation on all the C data types. So see you in the next video. So thank you guys.